What they will do is, yeah, sure, that's right. What they do is they stick. Here's the cliff, right? Here's the tree. This is what they showed me last night. Right, you got the anchor. I don't know whether you tie it around there. You do webbing. Probably they're going to do webbing, right? And then at this point, they're going to do a loop, right, in the rope. Probably a figure 8 on a bite or a butterfly knot or something like that. That's right. Yes. Yeah. You got it. Right. And then there we are. We'll be doing that, right? And then what's kind of fun is that you also are standing there or sitting there, right? And you're actually going to take this rope and stick it through a locking carabiner, attach that to your harness as well. So you've got your personal protection and whatever to this thing. I'm going to check those anchors out. Because we're just relying on that one anchor. That's right. If I had my preference, I would have a static line to my own anchor, right? And then, although that might be kind of dodgy, right? Because if you have a static line to your own anchor, then that static line is going to take all the load, right? This is like 50 feet sometimes, because at Horse Thief Butte, apparently it's just like a lot of nothing. I've never been there, but like big flat rock, nothing to tie onto. Yeah.
One main anchor and the one that's like more slack.
I suppose, yeah. Because you could do a static line. You could do a static line to your personal pro. I don't know. I'm thinking catastrophic fall, right? I think you'd want a dynamic that much. I don't know.
Or you could just have a really good climber that doesn't.
Although, it's your harness that's going to get destroyed, right? Right. So basically, your personal pro is attaching to your belay loop, and so is your belay device. So if there's a catastrophic thing, it's just going to tear apart that belay loop, which is, that would be a nuclear fall. I mean, hundreds of feet. Right.
That would be so cool.
Yeah.
So at that point, you can just put a bungee cord on and then bungee jumping.
That's right.
It's a lot more fun. There was a guy that went there though, and the cord broke when he was jumping.
That's not good.
Actually, he was fine because it broke at the very bottom, so he only fell like 10 feet. We should try to.
What is the distance to a point where the recession velocity is half the speed of light?
Well, so maybe it's a little more than that. But he fell in the water, so it's not like that. Yeah.
Yeah. Yeah. Yeah. Yeah. Yeah, you got it. Yep. 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 Huh. Yeah.
From the distance
Yeah.
here to Wall Street, what is the recession velocity of the economy?
Oh yeah, this is good. This is keep in mind that when we talk about expansion, okay, you're not expanding. And as some cosmologist mother said, Brooklyn is not expanding. Okay, things that are bound by like molecular forces and stuff like that. It's not like, right? Those are little nuggets in there that are not expanding. It's the space between galaxies, right? And to some extent within galaxies. Right? Remember, it's this is not all that fast. 71 kilometers per second is not all that fast as far as things that go. And we would go 19 miles a second. So it's reckoned around the sun that is the source of all the power. So that's like 40 kilometers per second, right? And that's our orbital speed around the sun, right? So this is not all that fast as far as things go. A megaparsec is just a buttload of distance. So this Hubble expansion is a fairly subtle thing. Now, we just went to half the speed of light here, right? at fully the speed of light, wouldn't it be about twice that distance? Yeah?
Yeah.
And at twice that, the distance actually is about 13.7 billion light years, if you figure it out in light years. I just did it like this, right? The age of the universe is 13.7 billion years, right? And so this number is intrinsically tied, this Hubble constant thing, right, is intrinsically tied to this whole age of the universe. And how we know that is another story. Yeah? Say it again. Oh no, the universe is expanding. In fact, the rate of expansion is increasing, okay, when it should be decreasing, right? So something like the cosmological constant is going on, although it's not that. It's like, say it again.
Because you said that both things are 13.7 billion.
Yeah.
So are both those numbers going to go up?
Yeah, sure. The universe is expanding, and it's also getting older, right?
The rate of expansion is increasing?
Yeah, we would predict with gravity that it would at least be slowing down. Maybe not at a rate enough to bring it to a halt, but it should slow for sure. Right now, there's some other force besides gravity stronger than gravity,
Yeah, dark.
right? It could have something to do with the fact that there's 90% of the universe that we can't see and can't account for in any.
Which is
Yeah, we just call it that. We don't know what it is, right? We don't know.
How do we know it's 90%?
you call it dark energy.
Oh, how we know that? Yeah, that's we'll talk about that. But it has to do with like surveying, looking at galaxies. The motion of galaxies spin too fast. We know how much matter there is there because we can look at the stars, right? And there's just not nearly enough visible stuff. You know. Okay, so what does it mean that every galaxy is moving away from us? Well, okay, it means the universe is expanding. We did the rubber band. Is our position unique? Well, no. Okay, so here's before, here's after. I stole this from some guy's lecture at OMSI, right? Here's the before picture. Here's the after picture. Notice I just took these guys and just made them bigger. Yeah. Okay. So let's say that we are that galaxy. These are all galaxies in a strangely ordered universe, right? Okay. This is after. Notice that I just superimposed that dot so it's exactly on that. Notice that everything's moving away from that dot, right? And the farther away, the farther it moves in a given amount of time, right? Now let's say that we're that dot. Well, if we're that dot, then after is in the same place, right? And now every galaxy is moving away from us. Let's be that dot. Everything moves away from that dot too. And even a corner dot, right? Everything moves away from it, right? It's wondering, though, what's in this space where nothing's mapped. I don't know. You're just on the edge of the map, buddy. You know, there's cheese after that or something. Right?
That'd be a fortunate.
That's right.
Did this get PowerPoint of the year?
Yeah, I stole it from. Okay. So here's the story, right? Did I tell the story about the juggling bag?
No.
Oh, okay. This is probably not YouTubeable, but